This video serves as an introduction to titration curves. Alright, so let's remember what a titration is. In a titration, you're always going to have a substance that you're trying to quantify, and that is what we call the analyte. You generally put that in a flask. This is your analyte. And generally, you just want to know what is the concentration or the amount of that analyte that you have. And the way that you do it is by making it react with a titrant, which you put in a burette generally. Okay, this is the titrant. And the titrant has known concentration. It's something that you can control. Right? So the idea is that there's going to be a reaction between the analyte and the titrant that you know, and then through stoichiometric calculations, if you know how much titrant you have added, then you can figure out what is the concentration or the amount of analyte that you had. Right? Here, what we're going to be doing is looking at acid-base titration reactions. Okay, but the overall goal is going to be to establish a quantitative description of how the titration process works. As a matter of fact, what we're actually going to be doing is mapping how the pH in an acid-base titration changes as a function of the volume of titrant that you're adding. Okay, so that is actually what is called a titration curve. Okay, again, titration curve, you're adding an acid to a base or a base to an acid, and therefore the pH is going to change. And our goal in the next few videos is going to be to map exactly, quantitatively, how that change in the pH happens as a function of the volume of the titrant. Okay, so this is what a titration curve is going to look like. You're going to have the pH as a function of the volume of the titrant added. Okay, well, it turns out that there's only two ways that these curves can look like. Okay, so if your analyte is an acid and then you have base, you add base as a titrant, then when there's no titrant initially, you only have the acid. That means that the pH will be very low. But then as you add base, the pH will increase until you reach the equivalence point. And if you continue to add base past the equivalence point, then the pH will continue to rise until it becomes very high. Right? So for that type of titration of an acid with a base, these curves are going to have what we call an S shape. Okay? They're going to be something like this. Okay? The point of maximum slope corresponds to the equivalence point, which again, that is when you generally use an indicator to finish your titration. Okay? That is equivalence point, and again, that is the point where you have equivalent amounts of the acid and the base. Okay? So again, there will be an acid being titrated with a base. However, what you can also do is try to use a base as your analyte and then titrate that with an acid. Okay? So in that case, the pH curve will be a little different. Right? The volume of titrant at that point, okay, as a function, or pH as a function of the volume of titrant here, will be different. Notice that if you have a base in your flask, that is your analyte, and the initial pH should be larger than 7, so it will be large. Okay, but then as you add acid, which is again your titrant, as you add the titrant, the pH should drop because you're adding acid. Okay, and eventually you get to the equivalent point. But if you go past the equivalent point because you're adding acid, then the idea here is that the pH will continue to drop. Okay, so the way that those curves are going to look like will be something like this. Okay, so notice that there is some symmetry, but some difference as well, right? S-shape will be when you're titrating an acid with a base, but Z-shaped is when you're titrating a base with an acid. Okay. Now, there's only three types of titrations that we're going to be looking at. You can titrate a strong acid with a strong base, okay? So that is one of them. And then you can have an analyte that is a weak acid and titrate that with a strong base, or you can have an analyte that is a weak base and titrate it with a strong acid. Never you can use a weak acid or base as the titrant. If you have a weak acid or weak base, they will always be the analyte. Your titrant has always has to be strong. Okay, so it turns out that the shape of these curves really does not matter much or does not depend much on whether you have a weak acid or a strong acid as the analyte, or a strong base or a weak base as the analyte. There will be some slight differences in the region of low volume here and there, okay, but for the most part, the rest of the shape will be pretty similar regardless of whether you have a strong or a weak acid or base. All right, so this video has served as an introduction to the concept of the pH curves, and in the next videos we're actually going to be going through the cases, right? So we're going to develop quantitatively how to map this pH curve for a strong acid, strong base titration, and then we'll do it with an analyte being a weak acid and titrated with a strong base, or the analyte being a weak base and titrated with a strong acid.